We've always dreamed of infusing our bodies with technology. Sure, there are opportunities to heal ourselves, but we can also improve our vision, strengthen our bones, and we're even getting pretty good at replacing lost limbs. Thing is, there's a problem.
Electronics and body fluids do not mix. The environment within your body is actually quite corrosive to the kinds of materials that you normally have in your iPhone or something like that.
But what if electronics behaved less like metal and more like the materials that make up our bodies? In a basement lab of MIT, a team of researchers has the answer. Most electronics we interact with are dry and hard, unlike the inside of the human body. But this synthetic material is somewhere in between those two. It's called a hydrogel. What is a hydrogel?
A hydrogel is a polymer network infiltrated with lots of water. For example, jellos we eat, hydrogels, right? If you look at the composition of the body, human body, except teeth, bone, and a nail, all other parts, they are hydrogels.
We are hydrogels.
We are hydrogels. Actually, the majority of human body are hydrogels.
Xuanhe's hydrogels, while synthetic, are biocompatible, able to exist within the body without any adverse reaction. His goal is to encase electronics like these sensors inside the gel, which can then be implanted in the body. This isn't a new idea, but it's never worked before because of the properties of traditional hydrogels.
So I just wanted to show you kind of like some of the materials.
Right.
So what's interesting about our gels is this is like typical gels are like this. Try to stretch this. So that's kind of like a typical gel. You try to stretch it and it breaks really easily.
Right.
Now try stretching this one.
Oh. What? It's like a... Oh. What? It's like I'm making noodles. What's up? But that was pretty far.
Yeah, that's a good thing. This is very reliable, very stretchy.
Okay, I'll stop breaking it now. This new hydrogel has another benefit. It's sticky. So sticky that adhesion tests show a bond between the gel and a metal plate is stronger than the bond between tendons and bone. This stickiness is the breakthrough researchers have been looking for. Electronics bond to the gel, but the gel stretches with the body. To demonstrate a simple use of the gel, Xuanhe developed a prototype for a smart bandage. So this is like a super Band-Aid.
Yes.
That would deliver medicine.
Right, that's correct. So the idea is that this will sense something, either temperature, chemicals, or if you have an infection, antibiotic.
So if I need an antibiotic, what might that look like?
So for example, you see it flowing.
I see they coming in. And then over time, that medicine would diffuse down.
Correct.
On demand.
Yes.
Only when needed.
Correct.
Biocompatible electronics conjure futuristic images, but one of the most immediate and important functions is simply health monitoring, placing sensors in our bodies that can collect data on what makes us healthy and what doesn't.
A lot of these technologies are going to be employed in chronic diseases that affect millions of people. Everything from cardiovascular disease, type 2 diabetes, schizophrenia, to depression. These technologies are going to be part of our future because chronic disease is not going away.
Looking forward, what do you see as the timeline for your work making its way into people's bodies? How far off are we?
Good question. We need to get FDA approval. So still it will take some time, probably on the order of a few years.
We've long known that electronics in the body could help improve and extend human life. This hydrogel is an important first step in that direction. It will not in and of itself cure a disease or fix a